right, so I told you that this is a square. I've graphed it for you. Now you need to algebraically prove that it is a square. So on your checklist, a square tells you that you need 4 congruent sides. We're going to have to show that either using the distance formula or Pythagorean theorem. We also need to show that opposite sides are parallel and that adjacent sides are perpendicular, meaning we need 4 right angles here because it's a square. So let's start with our slope. Let's find the slope of AB. I'm going to count my rise over my run. That's up 1, 2, 3, 4. So rise 4 and write 1, 2, 3. The slope of AB is 4 over 3. Now, if it is a square, which I know it is, I should be able to say that DC is also the same slope because they should be parallel. So let's find the slope of DC. Counting up, 1, 2, 3, 4, and I'll have to go right 3. I was correct that AB is parallel to DC. Why? Because we just showed they have the same slope. Let's check out these other 2 sides. What about the slope of AD? I'd have to go down 1, 2, 3. So down 3 and write 1, 2, 3, 4. Down 3, right 4. That sounds like the opposite reciprocal of 4 over 3. I'm thinking that now I'll be able to say that AD is perpendicular to AB because these slopes are opposite reciprocals. Negative 3 over 4 and positive 4 over 3 are opposite reciprocals. Now I've proven one right angle and I've proven one parallel, but now I need to go and say that BC is parallel to AD. So let's find our slope here. We'd have to count down 1, 2, 3 and write 1, 2, 3, 4. So the slope of BC is still negative 4 over 3. All right, that allows me now to say that AD is also parallel to BC. Now, the way that we can show that in geometry is we're going to put little arrows pointing in the same direction. They both have 1, meaning that this segment here is parallel to this segment. These, with 2, are parallel to each other. And we also said that this was a right angle between AD and AB because of that opposite reciprocal slope. Well, the same is true also for AB to CD. Here's AB, here's CB or BC. They have opposite reciprocal slopes. So I can now make this statement that AB is perpendicular, forms a right angle because of the opposite reciprocal slopes to BC. All right, so I've proven that we have the right angles. I've proven the parallel sides. Now I just need to show that the sides are the same length, meaning I can use the distance formula or I can use Pythagorean theorem. It looks like I already know the side lengths for this triangle here. I went to the left 3 and 4 here. Well, here it was 3 and 4. Here it was 4 and 3. Oh, all of these are the same. So I know if I work out the Pythagorean theorem once, that this distance is a 4 by 3 kind of triangle. So if I do a squared plus b squared equals c squared, I get 9 plus 16 equals c squared. Well, 9 plus 16 is 25. I don't want c squared though. I want c all by itself. So I'm going to do the inverse of squaring by taking the square root, and I know that c equals 5. That means the length of each side of this triangle is 5. So from here to here, that distance is 5. The hypotenuse from here to here, that distance is 5. Here to here is 5. Here to here is 5. So I can say all sides are 5. So it is a square. Let's reflect on the process. I had to prove that the opposite sides were parallel. I did that with the slope formula. I needed to prove that there are right angles. So with those slopes, I looked for opposite reciprocals. Last but not least, I used Pythagorean theorem, although I could have used the distance formula to show that all the sides were the same length with 5. Therefore, I can conclude that it is a square.